Well, ladies and gentlemen, I'm very happy to introduce our next esteemed wizard, who is a seasoned program manager with 15 plus years of experience in the IT industry. She is a true leader with a proven knack of bringing structure to the agile and DevOps process. Having earlier worked as a program manager at EA and Microsoft, she is currently serving as the product director at GitHub. And now she's all set to deep dive into all the various ways we can stop vulnerabilities at the source. Ladies and gentlemen, allow me to hand over the strings of this power packed session to Divya Vaishnavi.
Hello, everyone, and hope you're having a great DevOps India Summit, our first virtual DevOps Summit 2020. So, I'm from GitHub, and I'm going to talk to you about stopping vulnerabilities at source. To introduce myself, I am Divya Vaishnavi, Director of Product at GitHub, and I've been a developer. So, I started as a developer and then moved to product. You can find me on GitHub as Divya is, or on Twitter as Divya Vaishnavi. Now, I find the impact and the cultural transformation that DevOps brings very inspiring. I have a confession to make. So, I'm not an expert in security, but given the focus on DevSecOps and our theme this conference, what I wanted to do was share with you what GitHub does and how and our approach in making DevSecOps a part of your daily dev process. So before we go there, let me first share the state of security today and where we are. While some breaches are a result of human error or social attacks like phishing, the majority of breaches are a result of hackers' weakness in applications. Yes, 53%. And it's clear securing the applications you create is business critical. These numbers don't even include the security incidents that might not become breaches. Incidents such as DOS have devastating effects on business and are also typically exploited because of application vulnerabilities. We have a finding. More data, there are more problems. GitHub data science team did analysis of major OSS projects over a 5-period time frame. And what we found was there's a stubborn link between lines of code and security threats. And unfortunately, what it says is we're not getting better. We're not getting better at preventing security vulnerabilities from entering our applications, despite the focus on DevSecOps, despite the increased amount of time and attention spent on vulnerabilities. The number of security issues introduced into open source projects have grown steadily with the size of the projects. And there are a bunch of reasons for that. One of them is security researchers are hopelessly outnumbered today. Yes, there is one security researcher for 570 developers. You heard me right, 570. Given this number, the best these security researchers can do is reactive. How can we even imagine them proactively giving timely analysis to prevent vulnerabilities? We all know the focus of DevSecOps, but in so many organizations is still an aspiration, rather an achievement. This graph shows the static analysis scans and the frequency of them for folks that are running static analysis already. As you can see, less than 10% of folks that are running security scans are doing that more than once a week. And nobody is scanning at every commit. We haven't really embedded security in our developer workflow. We've better processes of security teams, better toolings for them, but it's not yet the responsibility of the developer. And when it's not the responsibility of the developer, it's not something that can really prevent vulnerabilities before it enters our application and lands in our production. And don't forget, this data is only for applications that are using static analysis, that are doing security scans. As most of you know, and I know, the vast majority of us are actually not doing any automated security runs in our applications. So, what do we do? What's the solution here? The obvious solution is shifting left. Let security also shift left. Given the enormous cost of breach and the security and the scarcity of security resources, who can harden our applications to address the security concerns, the idea is to bring security and scanning as part of our development process. As you can see in this graph, with each step that it moves backwards, the remediation cost reduces. But how do we really shift left in security? And this is where I wanted to introduce to you GitHub's automated code scanning. This is something that is still in beta, and we've recently launched to help solve this exact problem. Let's go in details here. So the idea is very simple. It's that we introduce security review as part of your automated process at the time of pull request. This diagram here shows your age-old Git flow, where you branch off, you do a commit, make some changes, maybe have some discussions, make more changes, address the feedback, and then in the end, it actually goes and merges back with your master. Automated code scanning inserts security review at pull request time and in every commit that you make after the pull request. So it is part of your pull request cycle as well as part of every change you make post that. And it also allows you to run security scans on your master so that you do periodic checks, and any changes that are introduced in the code or new vulnerabilities that are found can be found in this scan, even when the change is no code is getting changed. So all the time, you've got the latest security research running against your repository. Let's dig deeper and get to the demo for this. So let me quickly show you a demo. What I have here is a simple website. It's a JavaScript website running a calculator on the web. Now, all you have to do is actually go to security and set up code scanning. Now, our code scanning integration is actually based in actions, and thus you can leverage all the capabilities that comes in action. But before I go to and set up this workflow, I wanted to call about our extensibility. We have partnerships in GitHub that, and the way we've built this is extensible. We have the right APIs already created so that other experts in the industry can integrate and you can leverage them. So we have shift left, Robocop linting, Anchor container scan already available as capabilities. And there are newer capabilities like Sonar Source container scan coming in the market as well. So you can leverage all of these capabilities in addition to what GitHub provides. So to set up this workflow, what I do is, like I said, leverage actions. So if you're familiar with YAML, this goes ahead and sets up a workflow. Again, like in actions, it is very configurable. So you can decide whether you want it on push, like what branches, all of those configurations you can do. Note here, what we support in terms of languages right now is C#, CPP, Go, Java, JavaScript, and Python. And we plan to add on more languages, but these are the default for now. Everything else by default is more or less set up, so you don't need to actually do anything. Let me commit this file and get code scanning started, which means it'll do it on every PR as well as a scheduled CI job. I have another example here where this was already set up. just to not like make sure I don't waste your time, what you see here is the job was completed. And if I go to the details here, you will see it's done the code QL analysis and given the results. Now, going back to our presentation here, in summary, what we saw was automated code scanning in action and our automated scanning capabilities that natively are integrated in your developer workflow. But it's really important to mention here that our static application security scanning capabilities is powered by the most advanced semantic code engine, which is CodeQL. CodeQL queries are open source and powered by a strong community, including the security coalition of organizations such as Google, Microsoft, Uber, Tencent, and a few more. CodeQL allows your team to treat code as data, and it enables them to create their own queries to account for the policies, security requirements, threat topologies of your specific code base, for your topology, for your environment. And CodeQL has found to be extremely effective at modeling vulnerabilities. And it makes our security researchers considerably more effective. What we found is more CVEs than any other static analysis tool have been found. And like in the last 3 months itself, there are 50 additional CVEs which were found by GitHub security scanning. Just to summarize, combining CodeQL with the largest developer community, which is GitHub, gives the next generation SaaS performance. It's just very happy to share, like 72% of fix rate for potential vulnerabilities flagged in open source projects, or like 18% of recent JavaScript CVEs would have been found by default CodeQL query. So no additional work required by the security team as well as by developers, just enabling this CodeQL workflow in your developer process. So if you enjoyed what you saw and want to make sure you have security profile corrected, go ahead, sign up for our beta here, and you can leverage these functionalities. So I went deeper into code scanning and helping showcased what we have. Now what I wanted to do was draw that bigger picture for you and share what GitHub's vision here is. So GitHub is on a mission to solve software security issues within the developer workflow. This means offering tools and methods to secure the entire application and the entire topology. Like I said, we went in detail about code. So making sure your code is secure and it catches vulnerabilities before it goes into production. And the second one is securing your supply chain, securing your dependencies, open source, inner source, other components, and all of that. And then reporting and understanding of where your dependencies are for your project, for your repo, or for your organization. So if I move ahead to supply chain, like what do you mean by supply chain? It's anything that you depend on to deliver your product. Right? So for software supply chain is anything that touches your code from development to production. And when I say development, it's like who wrote it? Where does it come from? Who contributed to it? And obviously through your CI/CD pipeline until it actually reaches production. And from security point of view, and to understand your risk profile, you would need to know how it has been reviewed for security issues. Are there any known vulnerabilities? Am I picking up vulnerabilities from the dependencies that I'm taking on? You know very well, software dependencies are pervasive. It's normal for your project to use hundreds or even thousands of open source dependencies that you didn't write yourself. Our data shows 80% of code in the average application is in dependencies. That is, someone outside your organization has written it. Detecting and acting on these insecurities in these dependencies is vital to securing your application. Like I said, it's normal for your project to use hundreds or even thousands of open source dependencies. And if any of these dependencies has a vulnerability, chances are you have that vulnerability too. So being able to leverage the work of thousands of open source developers means that thousands of strangers effectively have commit access to your production code. So make no mistake, if there is, say, an innocent mistake or a malicious attack, your supply chain affects you deeply. Now, this is very core to GitHub, given we want to flourish this open source community. We have capabilities which are available to help secure your supply chain. And we have two buckets here, so to say. The first one is knowing your environment. That is, having a deeper understanding of what your dependencies are, understanding of this with respect to, again, your project or at your organization and repo level. And the second one is managing your dependencies, understanding, again, and as automated as possible, of what those vulnerabilities are and how can you fix them. So if I talk about dependency graph, to know what dependencies you have, we have something called dependency graph. Dependency graph identifies all upstream dependencies and public downstream dependencies dependence of a repository or a package. So you can see your project dependencies and some of their properties like vulnerability information. To generate this information, what we actually do is we need read-only access to your repositories to access this information on explicitly declared dependencies, which usually, say, like in npm, is in your package.json file. So we parse that package manifest file and create a dependency graph, so to say. So items are added in the dependency graph when you add a new dependency, as well as when you push a change to the default branch that would change this manifest file. Dependency graph on public repos is on by default, but for private repos, it needs to be enabled specifically. Now, once we know your dependencies, we want to know when they have new vulnerabilities. Security alerts for dependencies notify you of repositories affected by newly discovered vulnerabilities. To do this, GitHub compares the information in the dependency graph to the information in GitHub's advisory database. So you get an alert from Dependabot, which is our internal bot, when either a new dependency is added and there are checks on that dependency, or a new vulnerability is discovered by already known dependencies for you. So the alert is sent to the GitHub repo owner by default. Again, this is set up by default and enabled for public repos, but needs to be opted in and enabled for private repos. So we understood knowing your environment, which is identifying the dependency graph and creating them, and then the dependency alerts. Now, once we know there's a dependency, you would want to patch it. And how about making that automated as well? We've done work here too. So what you have is Dependabot will send you a pull request to update dependency to the minimum version that resolves a known vulnerability. That is the next version with the patch. A small change is easier to review, and that's why the next version and not the latest version. And this is again done automatically based on known vulnerabilities and known patched versions. Dependabot security updates create a PR to update package dependencies in the log file by proposing changes to your log file or changes to your JSON files. Once you turn on dependency graph and security alerts, depend-upon security updates are automatically enabled. Let me again give you a demo of that. So here I have to enable it. All you have to do is go to security and enable depend-upon alerts. Again, you can enable the alerts as well as the automatic PRs that I spoke about. So if I do that, it'll actually go ahead and start creating your dependency graph as well as identifying if there are any alerts and generating PRs for that. Again, to save on time, what I've done is created and set this up for one of my repos. And what you'll see is when I click view depend about alerts, there are 5 depend about alerts here, and with severity details too. You'll also see there are these pull requests which are created. Actually, sorry, let me go back to these and let's just look at one of the critical severity ones. So what you'll see here is there the details of that alert with the remediation, the details as well as like the CVE details as well. So you can actually browse to this and go and look in additional details. Plus, it's generated this PR by default. So if I go to this PR, again, what it does is has everything. So if I see the files changed, it'll have like the JSON and change the dependency version for those vulnerabilities. All I need to do here is just merge this pull request and I'll be all sorted for this specific vulnerability. So what we've again tried to do is automate as much as possible, as well as learn from all other open source contributors who are helping with these CVE information, with the ability to remediate these issues and made it as much automated as possible. So going back, what we found was for repos that have dependency bot security alert setup, the mean time to recovery, which is your MTTR, actually reduces. So in general, it's around 180 plus days, like is the industry norm of MTTR. But with Dependabot setup, it actually reduces and goes to 40 days. And again, it is mainly based on this alerting as well as auto PRs that help improve this MTTR and make it all automated. The last bit that I wanted to touch upon was reporting. Now, this is mainly understanding of like the dependency graph information for your organization so that you have a high level risk profile and understanding of your security and your vulnerabilities, your exposure at a repo as well as organization level. So it gives you that quick auditing capability, so to say, and find dependencies with GPL licenses. This is all I had with respect to GitHub and all the amazing work that the security team is doing. If you want to learn more about GitHub and its security, you can actually go to this link, which has more details. And like I had shared before, you can actually sign up for automated code scanning for beta. I think it'll be GA in few months, post which everybody can leverage that. Thank you again for this awesome opportunity. And if you have any questions or you want to reach out, you can find me on Twitter at Divya Vaishnawi or on my LinkedIn handle or my GitHub profile too. Thank you so much.